Hi students, this is Sivakumar. 11th Standard Mathematics, chapter number 3, continuation of exercise 3.8. Now problem number 2. Solve the following equations for which solutions lie in the interval 0 degree less than or equal to theta less than 360 degree. Look at the symbol here, less than or equal to here, less than. That means including 0 degrees and excluding 360 degree. 4 subdivisions are there, we can do one by one. Here is subdivision number 1, sin power 4x equals sin squared x. You must be knowing that one. In first quadrant, the solution theta that is equal to alpha. In second quadrant, theta that is equal to 180 minus alpha. In third quadrant, theta that is equal to alpha minus 180. And fourth quadrant, the solution theta that is equal to minus alpha. 0 degree to 360, 0 to 360, anti-clockwise direction, full of positive angles. Positive direction, so positive direction. Okay. Now, sin power 4x that is equal to sin squared x. You are not supposed to cancel sin squared x here because x is a solution here, so that it should be taken to the left hand side. Sin power 4x minus sin squared x that is equal to 0. Now you can take sin squared x as common. If you take sin squared x as common, you will be getting sin squared x minus 1 that is equal to 0. Product of these two equals 0 means either sin squared x equal to 0 or sin squared x minus 1 equals 0. Now consider that is case 1. Case 1, I take sin square x that is equal to 0. Taking square root on both sides, we will be getting sin x that is equal to 0. Square root of sin squared x is sin x and square root of 0 is 0 only. Now, if sin x equal to 0, you know the general solution x that is equal to n pi, where n belongs to set of all integers. Here, set of all integers, that's all negative numbers, positive numbers, including 0, that is set of all integers. But we can consider only positive numbers, because if we consider one negative number, I consider n that is equal to minus 1 into pi minus pi. So minus pi, that is minus 180 degree, it doesn't lie in this interval. So have to consider only positive value including 0. Okay, I take 0 when n that is equal to 0, x that is equal to, if we replace n by 0, 0 into pi that is equal to 0. When n that is equal to 1, if we replace x by 1, 1 into pi, pi. 0 in radian, or you can write 0 degree, or pi can be replaced by 180 degrees. 0 degrees and 180 degree both lie in this interval. So both can be considered. But no chance of taking n that is equal to 2. If we take n that is equal to 2, if we replace n by 2, 2 into pi, 2 pi. 2 pi that is equal to 360 degree. 360 degree is excluded here because you are given strictly less than. So we can go up to 1 only. So we have double solution. Now sin squared x minus 1 equal to 0. Case number 2. Case number 2. Sin squared x minus 1 equal to 0, which implies sin squared x that is equal to plus 1. Minus 1 comes right hand side plus 1, taking square root on both sides. Now if you take square root, sin squared x, square root is sin x. Since we have square, we have to introduce plus or minus. Square root of 1 that is equal to 1. So sin x that is equal to 1 or sin x that is equal to minus 1. Sin x that is equal to 1 and sin x that is equal to minus 1. For sin x equals 1, this can be replaced by sin pi by 2. You know very well, sin 90 that is equal to 1, sin 270 that is equal to minus 1. So sin x that is equal to sin pi by 2, which implies x that is equal to pi by 2. Or you can say 90 degrees. Here sin x that is equal to, we have minus 1, the minus 1 can be replaced by 3 pi by 2 because sin 270 that is equal to minus 1. which implies x that is equal to 3 pi by 2, or we can say that is 270 degree. Finally, write the solution. You write them in order. So here we have two angles, one is 0 degree and 180 degree, and here 90 degree and 270 degree. So we can write them in order: 0 degree, 90 degree, 180 degree and 270 degree. So I have represented the angles in degrees. Even you can write you can represent the angles in radian. 0 degree, that is 0, 90 degree, that is pi by 2, 180 degree, that is pi, 270, that is 3 pi by 2. That is a solution. Okay, so subdivision 1 is over. Now subdivision number 2. Here we have second subdivision. So write 2 cos squared x. It comes left hand side plus 3 cos x plus 1, that is equal to 0. Okay? It is a quadratic equation in terms of cos x. It can be splitting the middle terms. You can go for factorization. The coefficient of cos squared x is 2. 2 should be multiplied with the constant 1. 2 ones are 2. And the coefficient of cos x, that is equal to 3. Product 2, sum 3. The two numbers are 2 and 1. 2 and 1. Right here 2 cos squared x plus 3 cos x can be written as 2 cos x plus 1 cos x plus 1, that is equal to 0. Here grouping first and second, you can take 2 cos x as common. If you take 2 cos x as common, you will be getting cos x plus 1. Here nothing common, you take 1 into cos x plus 1, that is equal to 0. Here between these two, you can take cos x plus 1 as common. If you take cos x plus 1 as common, you will be getting 2 cos x plus 1. 2 cos x plus 1, that is equal to 0. So product of these two equals 0 means cos x plus 1 equal to 0, or 2 cos x plus 1, that is equal to 0. Now case 1. I consider cos x plus 1 equal to 0. Cos x plus 1 equal to 0 means cos x, that is equal to, plus 1 comes right hand side, minus 1. You know very well, cos 180, that is equal to minus 1, which implies cos x, that is equal to cos pi. So x, that is equal to pi, or we can write 180 degrees. That is case number 1 over. Now case number 2, 2 cos x plus 1 equals 0. Case 2, 2 cos x plus 1 equals 0. So 2 cos x, that is equal to, plus 1 comes right hand side, minus 1, which implies cos x, that is equal to minus 1 by 2. Since cos x is negative, cos x negative in which quadrant? Here whole positive, sine positive and cosecant positive in second quadrant. Third quadrant tan and cot only positive, and the fourth quadrant cos and cosecant, cos and secant only positive. Here cos x is negative. In this quadrant cos is negative. Even in this quadrant cos is negative. So second quadrant and third quadrant cos is negative, right? So here you know very well that theta, that is equal to pi minus alpha. Already I given theta, that is equal to pi minus alpha. Here theta, that is equal to, since you are given that 0 degree to 30 degree, 360 degree, it's an anti-clockwise direction. Here you have to consider this is pi plus alpha. Note down. Here this is 180, pi minus alpha, pi plus alpha. Then only you can get the positive angles. Remember, even though I have given here theta, that is equal to alpha minus pi, here you have to consider pi plus alpha since angle in anti-clockwise direction. We can prove. So which one is alpha? Here we have half. Cos 60 degree, that is equal to half. We know that cos pi by 3, that is equal to half. So you have to consider alpha, that is equal to pi by 3. So which implies x, that is equal to pi minus what is here, pi by 3, or x that is equal to pi plus pi by 3. Instead of or you have to put a double solution, pi minus pi by 3 and pi plus pi by 3, that is equal to 3 into pi, 3 pi minus pi, that is equal to 2 pi by 3. Can directly write here x that is equal to 3 into pi, 3 pi plus pi, that is equal to 4 pi by 3. Or you can represent them in a degree. Pi by 3 equals 60, 60 into 2, that is equal to 120 degrees, that is equal to pi by 3, that is 60, 60 into 4, that is equal to 240 degrees. 120 degrees and 240 degrees. Here we have 180 degrees. All the three angles lie in the given interval 0 to 360 degree. So that is a solution. Therefore, solution, I write them in order. First 120 degrees. In case 1 we got 180 degrees and 240 degrees. Or you can represent them in radian. 120 degree, that is 2 pi by 3, 180 that is pi, and 240 that is equal to 4 pi by 3. So you may ask that, sir, you have mentioned theta that is equal to alpha minus pi. If we consider theta that is equal to alpha minus pi, we will be getting the same 120 degree. You can verify now. When alpha that is equal to pi by 3, theta that is equal to what I mentioned here, alpha minus pi, particularly this is in third quadrant, that is alpha is pi by 3 minus pi, that is equal to pi minus 3 pi, that is minus 2 pi by 3. Cos of minus 2 pi by 3, therefore cos of minus 2 pi by 3, that is equal to cos of 2 pi by 3, because cos of minus theta that is equal to cos theta. So what's the angle here? Cos 120 degree. Here it is, already we have. For getting this angle, you have to consider pi plus alpha, because you are getting the angle in anti-clockwise direction, 0 degree to 360 degree. So in this quadrant you have to consider pi minus 0 to 360 degree anti-clockwise direction, pi minus alpha, here pi plus alpha. Then only you can get two different angles. If we consider alpha minus pi, you will be getting the same angle 120 degree. So that is the reason of getting theta that is equal to pi plus alpha in third quadrant, remember. So these are the angles. Now third subdivision. Particularly this one is for your reference only, no need to write in the examination. I do one thing, I strike out that one. Okay. Now subdivision number 3. Here we have third subdivision. So 2 sin squared x, it comes left hand side minus 3 sin x plus 1 equals 0. Splitting the middle terms, coefficient of sin squared x equals 2, 2 into 1 that is equal to 2, and the coefficient of sin x that is equal to minus 3. Product to 2, sum minus 3, the two numbers are minus 2 and minus 1. Add together minus 3, multiply these two numbers, will be getting plus 2. Now 2 sin squared x as it is, instead of minus 3x you can write minus 2 sin x and minus 1 sin x, and at the last plus 1 equal to 0. Now grouping. Between these two you can take 2 sin x as common. You will be getting sin x minus 1. Here nothing common, right? So which is inside the bracket sin x minus 1, you have to write once again sin x minus 1. Since we have minus 3x, you put minus 1 here. Minus 1 into sin x minus sin x, minus 1 into minus 1 plus 1, that is equal to 0. Between these two you can take sin x minus 1 as common. If we take sin x minus 1 as common, we will be having 2 sin x and minus 1, that is equal to 0. So product of these two equal 0 means sin x minus 1 equal to 0, or 2 sin x minus 1 equal to 0. Case 1 and case 2. In case 1, take sin x minus 1 equal to 0. Sin x minus 1 equal to 0, which implies sin x that is equal to plus 1, which implies, you know very well, that is pi by 2. Sin 90 value is 1. Therefore, x that is equal to pi by 2. Or 90 degrees. Case 2, 2 sin x minus 1 equal to 0. Here it is 2 sin x minus 1 equal to 0, which implies 2 sin x equals 1, which implies x that is equal to 1 by 2. I mean sin x that is equal to 1 by 2. Here sin x is positive value. Here A, S, T, C. Here sin is positive. Here also sin is positive. Okay. In this quadrant, theta that is equal to alpha. Here theta that is equal to pi minus alpha. Okay. So which one is alpha? We know that sin x that is equal to sin pi by 6, that is sin 30. Sin 30 that is equal to 1 by 2. So what is given here? Sin x that is equal to 1 by 2. This 1 by 2 can be replaced by sin pi by 6. So x that is equal to pi by 6. So let alpha that is equal to pi by 6. Now sin x that is equal to sine of, so do one thing, you write the solution, theta that is equal to x that is equal to alpha, which implies x that is equal to alpha that is pi by 6, and x that is equal to pi minus alpha, which implies x that is equal to pi minus alpha, that is pi by 6, that is equal to 6 into pi, 6 pi minus pi, 5 pi by 6. Finally write the solution. Here pi by 6 that is 30 degrees. Here pi by 6 that is equal to 30, 30 into 5 that is equal to 150 degrees. Solution, you can write them in order. First 30 degree, 90 degree and 150 degrees. 30, 90 and 150 degree. Or else you can write them in radian, that is pi by 6, this is pi by 2, this one is 5 pi by 6. 3 subdivisions over. Now subdivision number 4. Here we have a fourth subdivision, cos 2x. Here we can apply the formula cos 2a in terms of sine, because we have sine in the right hand side. Cos 2a that is equal to 1 minus 2 sine squared a. I am going to apply this formula. Therefore cos 2x that is equal to 1 minus 2 sine squared x, that is equal to 1 minus 3 sine x, which implies here plus 1, here also 1 get cancelled, otherwise write 1 minus 2 sine squared x. It comes left hand side minus 1 and plus 3 sine x, that is equal to 0. Here plus 1 and minus 1 both get cancelled. So we have minus 2 sine squared x plus 3 sine x, that is equal to 0. Minus 2 sine squared x plus 3 sine x, that is equal to 0. To take sine x as common, if you take sine x as common, you will be getting minus 2 sine x plus 3, that is equal to 0. Therefore, sin x equal to 0 or minus 2 sin x plus 3 that is equal to 0. Here minus 2 sin x plus 3 that is equal to 0. Here sin x equal to 0. Now case 1 and case 2. Case 1. Sin x equal to 0. That's a general solution, you know very well. X that is equal to n pi. Where n belongs to set of all integers. Here we can consider n equals 0 and 1. Only already I told you in the first subdivision. When n that is equal to 0, x that is equal to 0 into pi that is equal to 0, or you can write 0 degree. When n that is equal to 1, x that is equal to 1 into pi, or you can write 180 degrees. Only these two. Suppose I take n that is equal to 2, we will be getting 2 pi that is equal to 360 degree. 360 degree is not included in the given interval. So I can take n that is equal to 0 and 1. Case 1 over. Now case 2. We have minus 2 sin x plus 3 that is equal to 0. So minus 2 sin x that is equal to plus 3 comes right hand side minus 3. Both minus get cancelled. So sin x that is equal to 3 by 2. 3 by 2 that is 1.5, which is greater than 1. Not possible, because sin x value lies from minus 1 to plus 1. The least value is minus 1, the highest value is plus 1 only. This is not possible to find the solution in this case. So finally we have only two solutions, only 0 degree and 180 degree. Solution 0 degree and 180 degree, or we can represent them in 0 and pi. 0 degree, here representation of angle in radian, 0 and 180 degree that is equal to pi. All the 4 subdivisions of problem number 2 completed. Then I will be teaching problem number 3 in the next video. Thank you, children.